Dear students, we were discussing about pH scale earlier and given so many data relating to pH of different solutions starting from pH 0 to 14. Now, how to get pH value for different solutions? That's what we are going to discuss now. You have to understand this very clearly because different types of calculations regarding pH will be asked. For all those I am going to discuss now. So this will be more useful for any even competitive examinations. So pH calculation. How to calculate pH of a solution? If a solution is very weak, let me give few points. If a solution is very weak in the sense less than 10 power minus 6 molar. Less than 10 power minus 6 molar means of the order of minus 7, minus 8 like that. If a solution, if an acid or base is very weak, that is less than 10 power minus 6, then contribution of hydrogen ion and hydroxide ion, the contribution of hydronium ions and hydroxide ions from that aqueous solution cannot be neglected. Cannot be neglected. What does it mean? If an acid or base, that is aqueous solution of acid or base, is very weak, then contribution of hydronium ions or hydroxide ions from that aqueous solution cannot be neglected. The meaning is, let me say an example, 10 power minus 8 molar HCl. If you take 10 power minus 8 molar HCl, what will be the concentration of hydronium ions? HCl in aqueous solution ionizes to form H3O plus and Cl minus ions. If 10 power minus 8 molar HCl get dissociated, it is a strong acid, it dissociates to form 10 power minus 8 molar hydronium. That's what we assume. If it is so, we will be calculating pH like this. pH is equal to negative log to the base 10 of hydronium ions. Here the hydronium ion happens to be 10 power minus 8, therefore as such we will be calculating mechanically. Mechanically you may calculate like this. If it is so, you will be getting minus into minus plus 8 log 10, which is equal to 8. Now you have to think in a different manner. How? pH 0 to 7, pH 7 means neutral. 0 to 7 as acid, 7 to 14 base. So, if pH is 8, what does it mean? It is a base. But here we mentioned hydrochloric acid. Is it possible? Is it possible? Not at all possible. It is wrong. It is wrong. What I have calculated here is wrong. Why? It is a weak acid. The acid is very weak. Less than 10 power minus 6 molar. Therefore, contribution of, if an acid or base is very weak, then contribution of hydronium ions and hydroxide ions from that aqueous solution cannot be neglected. We have to take it into consideration. That is the meaning. So, if water ionizes, you will be getting hydronium ions and hydroxide ions. How much of hydronium ion you will be getting? 1 in 10 power minus 7, because it is a neutral solution. That you have to add with it. When the solution hydrochloric acid become very weak, when the solution become very weak, the concentration of hydrogen ions is very much less. When compared to this, it become less. And therefore, that contribution we cannot neglect. And therefore, in our calculation, what we have to do is we have to add the concentration of hydrogen ion available from hydrochloric acid. Total is equal to concentration of hydronium ion from HCl from water. It cannot be neglected. When do we consider this? When the concentration becomes less. When the concentration goes like this, 10 power minus 7, minus 6, minus 8 like that. At that time we have to add. Now let me add. Hydronium ion from HCl is 10 power minus 8. From here it is 10 power minus 7. Let me say 1 into 10 power minus 1 into that. Then only it will be easier for you to do the sum. Summation will be easier. Let me take 10 power 7 on both sides. Here, then only I can add properly. 10 power minus 7 means, here I have multiplied by 10. It has to be divided by 10. Therefore, 0.1 plus into 10 power minus 7. Plus 1 into 10 power minus 7. Am I correct? I have converted 10 power minus 8 into 10 power minus 7. How? By dividing 1 by 10 and multiplying 10 power minus 8 by 10. Now the powers become equal. Now I can add. How? When I add, it will become 1.1 in 10 power minus 7. Now if I do the calculation for pH, it will be slightly less than 7 and therefore it will be acidic. Earlier when we were doing this calculation, it becomes 8, showing that as if it is a base. It is not a base, it is an acid. Hydrochloric acid can never become a base, it is acid only. How is it possible? Since it becomes very weak, very dilute, less than 10 power minus 8, the contribution of hydronium ion has to be taken into consideration for acid. If we take for OH, we will be adding OH. That's all. So, hydronium ions are available, one from hydrochloric acid, another from ionization of water. So, if we add both, the power 10 power minus value should be equal. I made these values equal. Therefore, it becomes 1.1 in 10 power minus 7. Now, if I do the pH calculation, I will be getting the correct calculation. So, this is how I have to get the hydrogen ion concentration. pH calculation I will be explaining afterwards. Hydronium ion concentration has to be arrived like this if an acid or base happens to be a very weak. For example, if sodium hydroxide is very weak, of the order of 10 power minus 6 molar sodium hydroxide, if I say, here also it is weak. 10 power minus 8 or greater, less than, even 10 power minus 6 means we can consider hydronium concentration. How? Sodium hydroxide, if it ionizes, it forms sodium ion and hydroxide ion, mostly forward direction. So 10 power minus 6 will give 10 power minus 6 molar hydroxide ion. Water also furnishes hydroxide ion, H3O plus ion and hydroxide ion. It will give 10 power minus 7 mole per decimeter cube always at 25 degrees Celsius. That we know. This value we know. At 25 degrees Celsius, this much hydrogen ion, this much hydroxide ion we will be getting. That value you know. So this much of hydroxide ions we are getting from water. If we add both, that will be the real hydroxide ion concentration. So hydroxide ion concentration is equal to concentration of hydroxide ions from sodium hydroxide from NaOH plus concentration of hydroxide ion from water, which is equal to 10 power minus 6 plus 10 power minus 7. How to add both? Both can be made 10 power minus 6. 10 power minus 6, 1 into 10 power minus 6 plus 1 into 10 power, if it is made 10 power 6, I multiplied it by 10, therefore 1 has to be divided, 0.1 in 10 power minus 6, which is equal to 1.1 in 10 power minus 6. So this is how we get the value. This point You should be very clear in your mind, very, very important. All right. If an acid or base is very weak, of the order of or less than 10 power minus 6, we should not supposed to take the concentration of hydrogen ion as such. If we take as such, the value may be wrong, totally wrong. It may lead to a conclusion that it is a base. It is not possible. An acid is always acid. All right. In the case of a base, also same thing we have to do. We have to add the concentration of hydrogen ion available. Concentration of hydrogen ion available from water. Only then we will be getting correct pH or pOH. If we do the calculation, we will be getting correct pH or correct pOH, whatever it may be. Now, second point. First point, I think you are very clear. Second point. In the case of a concentrated acid, if concentration is given in molarity, if concentration is given in molarity, then the given concentration, if the concentration is given in molarity, for a strong acid, of course, for a strong acid or strong base, whatever it may be, the given molarity has to be multiplied by the number of ions available from it. That is the basicity of the acid or acidity of the acid. Multiplied by the basicity of the acid or acidity of the base. What does it mean? Which is nothing but number of ions available from one molecule. That is the meaning. Number of molecules available from one molecule. Number of ions available from one molecule. For example, if I say 1 molar HCl, 1 molar sulfuric acid, 1 molar sodium hydroxide, 1 molar calcium hydroxide. All right. I have taken few. 1 molar hydrochloric acid upon ionization will give 1 mole of hydrogen ion and 1 mole of chloride ion. Or in other words, with water if I write, you will be getting HCl plus water, you will be getting H3O plus Cl minus. 1 molecule gives only 1 ion. Without water if I write, only 1 H plus. But if it is sulfuric acid, H2SO4, it needs 2 water molecules to furnish 2 hydronium ions and sulfate ion. 1 molecule of sulfuric acid furnishes 2 hydrogen ions. That is 2 hydronium ions. Because the basicity of the acid is 2. Here basicity of the acid is 1. Therefore, here the hydronium ion concentration is considered as just 1. 1 molar, therefore 1. Here 1 molar, but if it is multiplied by 2, it becomes 2 molar. All right? 2 moles. 1 molar. Suppose if I take 0.1, usually it may not be 1 molar, 0.1 let me take. 0.1. 0.1 molar HCl will give only 0.1 molar. But 0.1 molar sulfuric acid will give 2 into 0.1 molar, which is equal to 0.2 m. Don't forget, that is important point if it is given molarity. Likewise, sodium hydroxide ionizes to form sodium ion and hydroxide ion. Of course, strong acids completely ionized. 0.1 molar sodium hydroxide furnishes only 0.1 molar hydroxide because 1 gives only 1. Therefore, here hydroxide ion concentration is equal to 0.1 only. Whereas here, calcium hydroxide upon ionization forms calcium ion and 2 hydroxide ions. That means 0.1 molar furnishes 0.1 into 0.1, which is equal to 0.2 molar. So, for this acid, basicity 1. For this acid, basicity 2. For this base, acidity 1. For this base, acidity 2. Therefore, we have to multiply with acidity or basicity. But if the concentration is given in normality, if the concentration is given in molarity, the given molarity has to be multiplied by basicity of the acid or basicity of the acid to get the hydronium ion concentration or hydroxide ion concentration. Here, but if the concentration is given in normality, then hydronium ion concentration is equal to given normality, hydroxide ion concentration is equal to given normality. Why? One normal sulfuric acid, if I say, I have already divided molecular mass by its basicity, and therefore normality, if it is given, then as such molarity m, if it is given, normality means n. Therefore, 0.1 normal sulfuric acid is equal to hydronium ion concentration is equal to 0.1 only, 0.1 molar only for 0.1 molar sulfuric acid. Likewise, 0.1 normal calcium hydroxide also, hydroxide ion concentration is equal to 0.1 molar only if it is in normality. If it is in normality, the hydrogen ion concentration is equal to 0.1 mole per decimeter cube, hydroxide ion concentration is equal to 0.1 mole per decimeter cube, whatever it may be. For sodium hydroxide, calcium hydroxide, potassium hydroxide, aluminum hydroxide, everything, normality means taken as such, molarity means it has to be multiplied. That you should understand. Hope you might have understood. Alright. So, for a very weak acid or very weak base, concentration of hydrogen ion and hydroxide ion available from water should not be neglected. If it is a strong acid or strong base, if it is given in molarity, then to get the hydroxide ion concentration, it has to be multiplied with basicity of the acid or acidity of the base. Whereas if given in normal, it has to be taken as such. Points are very clear, isn't it? Next one. Few more points you should know. For a weak acid, of course, that you may be understanding well only after Oswald dilution law. But anyhow, let me try to say. Hydrogen ion concentration of for weak acids. For weak acids, they are not fully ionized. Until now, we were discussing about the strong acids, but weak acids are not fully ionized. And therefore, hydrogen ion concentration is equal to alpha C. You should know degree of dissociation and concentration. Concentration usually in normality. Or instead of alpha C, I can say root Ka into C, root of Ka into C, or Ka by alpha. These three formula you can use for weak acids. To get hydronium ion concentration, they should give two data. One, degree of dissociation and concentration, or dissociation constant of the weak acid and concentration normality usually, or dissociation constant and degree of dissociation. Degree of dissociation for 1 mole, always less than 1. Alpha will always be less than 1. Sometimes they will be giving percentage of dissociation. Percentage of dissociation 1, if it is given, it is nothing but 1 by 100. To convert percentage of dissociation into degree of dissociation, we have to divide by 100. Percentage of dissociation is equal to degree of dissociation alpha into 100. If degree of dissociation is multiplied with 100, you will be getting percentage of dissociation. If percentage of dissociation given and you want degree of dissociation, you have to divide percentage of dissociation by 100. That also you should know. Sometimes in the sum they will be giving like this. For weak bases, hydroxide ion concentration is equal to alpha C. Hydroxide ion concentration is equal to root of Kb into C, and the hydroxide ion concentration is equal to Kb by alpha. This we have derived from Oswald dilution law. I will be explaining you later. So using all these data given and the very simpler formula pH is equal to minus log hydronium ion concentration. Hydronium ion concentration is equal to antilog of minus pH. pOH is equal to minus log hydroxide ion concentration. Of course, to the base 10. Don't forget base 10. Hydroxide ion concentration is equal to antilog of minus PO. Of course, all these things I have given already in the last. Now, one more point I have to say. For minus value, we cannot take antilog. Suppose if the value is say minus 5.6, they are given. pH of the solution is pH is equal to 5.6. Calculate hydrogen ion concentration. So what you will be doing? Hydronium ion concentration is equal to antilog of minus 5.6. For negative value, we cannot take antilogarithm. So only for positive value, we take antilogarithm. Don't forget. Only for positive value, antilogarithm can be taken. Only for this value. When I write minus 5.6, 5 is negative, 0.6 is also negative, therefore it becomes 5.6. Do you understand? Minus 5 and minus 0.6 become minus 5.6. But if it is written in bar value, I can make it positive. How? I can add 1 to 5. I can add 1. If I add, it will become minus 6. Subtract 0.6 from 1. So you will be getting plus 0.4. The sum will be minus 5.6. So minus 5.6 can be given as a positive whole number and negative whole number and a positive decimal point. All right. Negative integer and positive decimal number. So 5.6 is nothing but 6 bar 0.4 I am writing. Minus 5.6 is nothing but 6 bar 0.4. Can you understand? So this conversion you need to know. Whenever you are asked to find out hydrogen ion concentration, you have to take antilog. For a negative number, for that number you cannot take. So make this number alone negative. How? Increase 1 with that. Minus number we have increased, therefore it becomes 6 bar, 6 minus 6. It becomes minus 6. And subtract 1 from 0.6 from 1. It will become 0.4 plus 0.4. This number become positive. Minus 6 and plus 0.4 together will give minus 5.6. That's all. So minus 5.6 we have converted. Now take antilogarithm for this number 0.4 into 10 power minus 6 will give the answer. This is how we do the calculations. All right. So I have given you the methods to calculate pH. What are the criteria which may be involved I have given. Based upon that, in the next class, let us go into solving different sums, pH, the sums which are given in the book as worked example as well as other things. Evaluate yourself. All those sums, let me try to solve. All the sums related to pH, POH, hydrogen, hydroxide in the next session. You will be understanding well. Thank you.